In this video, we're going to take a look at solving a rational equation that will end up involving a quadratic equation. Now, you can also see here that this does involve a quadratic equation in part of this rational equation. So hopefully that makes some sort of sense. So when you're doing these, you want to start by first looking at the denominators. If any of the denominators can be factored, we want to factor it. Now, this first fraction, I'm going to go ahead and pull this negative just up to the top so I don't forget about it, is negative 2x over x plus 3. X plus 3 can't be factored any more than that. Then I have minus 4 over x minus 5. This is another situation where I want to go ahead and just move this so that I don't forget about it. So I'm going to make this a plus a negative 4. And x minus 5 is fully factored. And then I have equals negative 32 over. And then x squared minus 2x minus 15. If I go through the factoring process, I am going to figure out that the two numbers that multiply to negative 15 and add to negative 2 are negative 5 and 3. So I have x plus 3 and x minus 5 here. Now that's really great because that means that these two denominators are both included in this denominator. So unlike some of our other problems where finding the common denominator can be a little bit tricky, it's actually much easier for these types of problems. That's because when I say that x plus 3, x minus 5 is, already covered over here and here, then I know x plus 3, x minus 5 is my common denominator. So I'm going to multiply each and every term by this, just like I did with the simple example. Okay, that came out with linear stuff. So I'm going to have this x plus 3, this x minus 5 multiplied here. I'm going to have x plus 3, x minus 5 multiplied here. You'll notice that these do take up just a little bit of space. So plan on that if you can. And if you can't, you can write it kind of vertically like I did there. And notice that I wrote to the right side here just for space purposes. Multiplication, you can do it either way. So when I look at this, I'm going to try and cancel some stuff as my first step. In the first fraction, the x plus 3 cancels. In the second fraction, the x minus 5 cancels. And in the last fraction, both the x plus 3 and the x minus 5 cancel. That means that in my first piece here, I have negative 2x times x minus 5. Here I have plus negative 4 times x plus 3. And over here, I just have negative 32. Now, we're really close to being in a super duper useful format. We're not quite there, but we're almost there because we still need to distribute and combine like terms in order to figure out how are we solving this. So I'm going to start by distributing my negative 2x, negative 2x squared plus 10x. Then I distribute my negative 4. Again, this is one of the reasons why I put plus negative, was just so it's easier to do this distribution step. And that gives me minus 4x minus 12. So really, when I combine my like terms, I have negative 2x squared plus 6x minus 12 equals negative 32. Now, I see that this is a quadratic. And if you remember from when we were solving quadratics earlier in the semester, we talked about how it has to equal 0 in order for us to actually go through the process of solving it. Right now, because it equals negative 32, that means I need to add 32 to both sides. This is now going to give me the updated equation of, let me go ahead and block this section off a little bit, just so it's a little bit easier to see that I'm going over. All right, here we go. So we have negative 2x squared plus 6x plus 20 equals 0. Now, I actually see here that we have a greatest common factor that is 2 or negative 2. So I want to get rid of that to make it easier to finish solving this. Now, remember, if it's an equation, you can divide through by the greatest common factor. If it's not an equation, if it's just an expression, so there's no equal sign, or it's part of a function, you need to factor it instead. But again, in this case, it is an equation. So I'm going to divide each and every number by -2. I am choosing -2 because it is easier to solve a quadratic if the leading coefficient is positive. So when I divide by the negative, it makes it a positive. So I now have x squared minus 3x minus 10 equals 0. At this point, you can solve the equation multiple ways. I'm going to choose to factor it. And when I do that, I end up with x minus 5 times x plus 2 equals 0. You can always double check that it works by multiplying it back out. And then when I solve each of these separately, so x minus 5 equals 0, I get x equals 5. X plus 2 equals 0, I get -2. Now, I want to point out, though, that we cannot say that these are the correct answers yet. We have to check each of them individually in the original equation. Now, this is again because sometimes things simply do not work with rational equations. It usually means that we have what's called an undefined value. And so if we have an undefined value, then it means that the denominator of the fraction is 0, which is a no bueno, not good. So I'm going to check x equals 5 first. Notice I'm going to plug it into the original form of the equation only. But everywhere there's an x, I'm going to replace it with the 5. That's on both sides of the equation. Now, another thing we have to know about simplifying these in order to check them is you want to simplify each side separately. Never move things from one side to another during a check, because sometimes that will make it seem like something works, even though it doesn't. So I'm going to simplify each fraction as much as I can. In this first fraction, I have -10 over 8. Okay, well, we can come back to that in a minute. Here I have 4 over 0. Okay, so over here, I'm going to go ahead, I'm going to show you how it would simplify, just for posterity mostly. 25 minus 10 minus 15 is also 0. Oh no, this is a problem. Okay, so when the denominator is 0, this is undefined. So in this case, we actually have two components that are undefined. Womp, womp, womp. So x equals 5 is not actually a solution. So we do not include it as one of our answers. Let's check our other possible answer. See if it works. Notice that if there is no solution, that means that any and all of the answers you found don't work. Then you need to put the empty set symbol, which is found in the math box. Just scroll through, you'll find it. Okay? But let's check the other answer that we found and see if we even have to use the empty symbol. Okay? So x equals -2 was the other possible answer. So we're going to have -2 times -2 over -2 plus 3 minus 4 over -2 minus 5 equals -32 over -2 squared minus 2 times -2 minus 15, question mark. Want to see if it's true. We're hoping it's true because then we'll have at least one answer. So let's see if we can simplify this at all. This one, -2 times -2 is 4. -2 plus 3 is 1. Minus 4 over -2 minus 5 is -7. Then here I have -32 over 4 is this piece. This is also 4. So I have 4 plus 4, because the negatives have canceled to give me a positive, minus 15. So that's 8 minus 15, or -7. So now, again, I don't do anything to the whole equation. I only use order of operations on each side to simplify as much as I can. So over here, I need to combine these two fractions. In order to do that, they have to have a common denominator. I'm going to multiply the top and bottom by 7. Also keep in mind, you're welcome to do this in your calculator, so feel free to practice with that if that's easier for you. But this is 28 over 7 minus, this is going to be minus a negative is plus 4/7 equals, this simplifies to positive 32/7. And when I combine these two fractions, it's also 32/7. So again, notice that I didn't move anything from side to side. I just simplified on each side independently, and the two sides do equal. So when I go back and think, what is my correct answer? X equals -2 is the only correct answer that I would put in to the homework system. I hope this helps a lot and it makes a little more sense about why some things work and some things don't.